Welcome back to Tech Search News, where we bring you the latest in the world of science and technology. Using our legs to perform a task is something that those of us who are fully mobile take for granted on a daily basis. Those who have experienced a complete spinal cord injury have had their lives forever altered. Being a paraplegic brings with it a set of lifetime challenges that the rest of us never consider. But what if there was a way to turn this around? A group of scientists has taken the first tentative steps toward a viable solution. Watch this episode till the end to learn more. This technology is so accurate that the patient can walk and stand immediately following surgery. 3 men were recently offered the opportunity to walk again in a clinical trial, thanks to a new technology featured in the Journal of Nature Medicine. The system consists of a spinal cord implant that encourages muscles and allows them to move once more. According to Grégoire Courtine, a neuroscientist at the Swiss Federal Institute of Technology and the co-author of this study, this technology is for the most severe type of spinal cord injury. That means individuals with diagnostically complete spinal injury, no sensation, no movement in the legs, he said, adding that the technology could be used for anyone suffering from a spinal cord injury just above the lower rib cage. So how does this technology work? When the spinal cord is damaged, signals from the brain cannot reach the target muscles, causing limbs to remain immobile because no sensation is felt. This is usually irreversible at the moment, but the motor neurons beneath the injury are still present. They're just dormant. The researchers used modified implants originally designed for pain management to resurrect the muscle neurons. It was essentially a repurposed version of an older technology that was used to block chronic pain by providing electrical current to neurons. Instead of trying to block the pain, the electrical current will be used to stimulate muscle neurons and cause the muscles to move this time. According to the paper, previous efforts focused on the dorsal column of the spinal cord, but this approach decided to focus on the spinal dorsal roots. The researchers believe that this will result in more varied and wider movement restoration in the most severe forms of spinal injury. Giving an electrical current to the neurons in the muscles is one thing, but it must be done correctly. In fact, the system must simulate electrical messages from the brain, so signal timing must be exact and done in such a way that the patient's leg muscles contract in a coordinated manner resembling a human step. This is referred to in the paper as, quote, natural activation pattern. As the research paper puts it, quote, targeting the individual dorsal roots with a predetermined timing can replicate the natural activation pattern of motor neuron activity while walking, end quote. But how will they figure out how to connect the system to the right neurons in the body? It's actually quite interesting. How did they go about it? First, the scientists took MRI images of 27 spines and fed those into an algorithm. The algorithm then generated a model of the average spinal cord. This included the size of the neurons as well as a map of their layout. So, what exactly was this magical algorithm? It is actually a program that has existed for some time. It's known as Sims for Life. The program could create models with finite elements of the spine, as well as produce nerve layouts and simulate voltages and electrical currents in neurons. Remarkably, these predictions meant that they could test the practicability of their systems without putting a live patient at risk. Everything could be optimized and evaluated in simulation, which is really pretty cool. They arrived at the final design after more fine-tuning and simulation. It was then time to put the device in place. 3 men were implanted with the device by neurosurgeons. All of the participants were paralyzed after their spinal cords were severed in separate motorcycle accidents. After a 10-day recovery period, the men began training with the device and corresponding software. Surprisingly, the simulations performed beforehand in the software proved to be correct. Within 1 day of activating the implant, all 3 participants regained some level of movement. This included the ability to walk on a treadmill. Their weight had been supported. The first few steps were incredible. A dream come true, says one of the patients, Mikkel Rukari. But it wasn't just walking. Participants were also able to engage in activities such as pedaling a stationary bike and squatting. All of their movements were guided by the device. It should be stated that the patients aren't fully walking yet, but as Reggie Edgerton, an exercise physiologist at the University of California who was also trying to work on spinal cord injury remedies, told Nature. The next question is whether stimulation over a long period of time will help the motor neurons develop the correct connections to perform the movements without stimulation, end quote. It sure is a waiting game for now. If this actually does happen, it could be huge. The system currently has 16 electrodes, but increasing the number of electrodes to 32 could provide better resolution movement. The team intends to conduct testing in the United States and has already received FDA approval. They plan to put the system through its paces in a larger clinical trial in the United States. The researchers intend to focus on people who have recently been injured because rodent studies have shown that animals recover more motion when stimulation begins instantly after their injury. They're also running tests on a brain implant that will send mental commands directly to the spinal cord stimulation machinery. This device may be capable of restoring other functions lost due to spinal cord injury, such as bladder control. As a result, there is a lot of activity being tested and done in the space. This work will give many people with spinal cord injuries reason to have a lot of hope, says Reggie Edgerton. However, they still suggest that we pause. First and foremost, it is still an invasive spinal surgery with its own set of risks. Other scientists are working on an expensive and less risky method that uses electrodes applied to the skin to activate the spinal neurons externally. Mikhail Rokati is pleased with the results so far. Quote, I use it now every day for a couple of hours at work, at home, to do a variety of things. It's now a part of my daily routine. It's fine. Working is essential, but simply trying to stand up can solve a variety of problems in everyday life. Perhaps just a simple shower without mobility aids. I can stand up and use the walker to take a shower. I'm no longer bound. I'm free to walk wherever I want. Right now? Okay. Now I'm working. There are many patients all over the world who require a treatment to combat paralysis. We have arrived at the point where we are ready to grow and advance and develop this treatment. We are working in collaboration with Onward Medical, who is developing all of the technology required to turn this result into a global treatment. We may have just witnessed those with severe spinal injuries take their first steps toward a mobile life. It's wonderful to see. That is all we have for today, and if you enjoyed the video, why don't you give us a like and subscribe to TechSurge News to hear the latest in the world of science and technology. Thank you for staying till the end of the video and hope you enjoyed. TechSurge News signing out.